I emailed you an exercise that comes from this section 12.5, and I plan to start today with working on this section exercises. Next Monday is final. And then I'll do the problem that I emailed. So we worked on this symbol of combinations that we already been working on for a while. I hope you're already familiar with word combinations, and that's the one that we're gonna use today again. So let me try problem number 29 that talks about a coefficient of x to the power of 6. In exercise number 29, I think I will need to share a board, but maybe I'll just do the problem first and then we'll expand this a little bit better. So the 10th power of x plus 3. So we need to utilize the binomial decomposition. Why is it called binomial? Well, because in the parentheses we have two terms. That's why it's called binomial expression, two terms, bi being two. If there are three terms, it's trinomial and so forth, but we don't deal with trinomial. So it's binomial decomposition of 10th power that will contain, turns out, 11 terms if you write them all out. And there is a formula that we tried to discuss last time here, and it's something like that. I guess we're not gonna really bother with shorthand of writing it, but we're gonna care about the terms here. So it decomposes with combinations. I'll be writing it as a combinations to choose. Now, it depends on what term you have. So the first term is always the largest power of x, so it'd be x to the power of 10, the largest. So the same power that we have here on the outside. And then the other term, which is 3, will be raised to the power of 0 because there's some of those powers. Some of those powers is always 10. So this enables me to see that we select out of 10 choices, out of 10 of these choices, all 10 x's. Since I care about power, 10 out of 10. And 3 is raised to the power of 0, so I don't care for it. Plus, notice that there'll be 11 pieces here. So we start at 0, then we go 1 all the way to the last one, which is going to be 10. So you have 1 through 10, there are 10, and then there's 0's 11th term. So the next will be dealing with x to the power of 9. And now 3, the other term, 3, will be raised to the power of 1, because the sum of powers must be 1 all the time. And it comes from the idea that you have a bunch of these parentheses multiplied, 10 of them, and then you select 9 x's and only 1 with the other term. So first power is 1, and so power of the other term is 1, and x is power of 9. And what's going to be the coefficient then? Well, out of 10 possibilities, so we'll always choose out of 10, there'll be 9 chosen. So I can put dot, dot, dot. I don't want to write all of these terms, but the one that we need will be with a power of x equal to 6. So if power of x is 6, then power of 3 will be 4, right? So what be the coefficient in front? Well, the coefficient will deal with selecting out of 10, 6. Okay. And etc. So their equation is not really what is this coefficient equal to, but what is x to the power of 6 is multiplied by. And that's the key thing to realize. Notice what they write in here when you are looking at the expression. So what's x to the 6 is multiplied by? It's going to be multiplied not just by these combinations, but also by 3 to some power. See, that's important to know. And then I will use a calculator because technically you could do by hand calculation of all that, but I would say this is a big number that definitely is helpful to use a calculator to deal with. So I'm gonna go for a favorite scientific calculator. It's a free one, choose Desmos, and go to the functions to get combinations. Remember, functions, that's the last row here. And then I return back to main. Now need to put 10, comma 6. So this is a pure calculator exercise now. Multiplied by 3 to the 4th. When you say it's 81, well, you could just let it be done by calculators. So 3 power of 4. So here's the number. It's a big number, 17,010. So all the answers for this exercise will be pretty big in most cases, and that's good to realize. So again, just pure x to the 6 is what I need to leave out, and everything else I can calculate, and I have to calculate. So let me do some more of these exercises here for a practice. That's what I've been planning on doing today. So let's try something with, like, say, 37. 3x minus 2 in the parentheses. Okay. And it's raised to the power of 9. Okay. So what do they want? Is not just to expand the whole thing, but they wanna the term number 3. Okay. The third term, which means that 2x, actually not 2x, but 3x will be raised to the power of 3. Let's see. Let's say, Alex, are you sure it's going to be a 3? Because if first term is power of 9, right? It deals with something that deals with x to the power of 9. Let me actually write it out so that 3x will be raised to the power of 9. Then the other piece, which is -2. Let's see, how come you use negative? Well, because we have the binomial formula that deals with the a plus b to the power of whatever, n, let's say. But if we have a difference, a minus b, then you could treat it as a plus negative b. You see, the idea is that negative sign is being observed by the second term if we have the difference. So you still want to have a plus, so that b term is negative, and it's gonna be raised to the power of 0, right? So 9 and then 0, sum is 9. And the combinations, now I just select from 9 the power that we have here, which is 9. And that's my first term. So the second term will be power of 1 less, so it'll be 1 less than first, which is 9, so it's 8. Right? And then -2 will be raised to the power of 1, because again, the sum now is the power of this parentheses, which is 9. The power is here. And the coefficient with that will be from 9, we choose 8. Okay, that's basically 8's power of x. So notice that it's different compared to, say, coefficient with x to the 6 or x to the 7, because this x to the 6 is not the 6th term in our decomposition, it's something else. So these problems are a little bit different. That's why I should be careful. So it's a second term. So now we go to the third term. Okay, so 3x now will be raised to the power of 1 less, which is 7. Right? 7. And -2 will be raised to the power of what? Squared, right? -2 squared, because the sum again of these must be 9, these powers. And then combinations, we choose 7 out of 9. So it looks like little by little we start to get used to these terms, and we don't need to write them all out because it's tedious and not needed. So you just put plus ... So my goal will be to calculate all that. And again, the third term in the expansion. So now you have to write out this whole third term. So I don't really care for coefficient. I just want to see what this is. So 3x to the power of 7. So it looks like x will be raised to the power of 7, right? It's going to have 3 in front, which is also raised to the power of 7. It's going to have this guy -2 squared. Well, -2 squared, I can multiply -2 by -2. It's just a 4. See, there's lots of other stuff around. That's why you have to be careful. And then this combinations thing, 9 choose 7, that I can write out using calculator. So the point is I can just multiply these 3 terms all together and put x to the 7th power in front and get the answer. So looks like let's go for functions, right? Combinations. So it is a little bit tedious, and we need to be a little bit careful without a rush to put this down and times it by all of that. 4 times 3, and there's a power of 6. So make sure that you have access to this online calculator. I highly recommend that you using it, or if you are familiar with some other calculator, redo the problem again with your own calculator, because something like that you will need to be able to do on the Monday final exam. In fact, I gave you an example of an exercise, and let me go to the email that I sent yesterday. So let's say if your B is 6, you can tell me what your B is if you want, and I can do it with your particular last digit of student ID. I think it'd be a good practice. So if in this exercise that I made up, the x minus 5 raised to the power of 10, we care about coefficient with x to the power of 6. So I need to write entire coefficient. Then x to the 6 The other term is -5 raised to what power? Sum needs to be 10, so it's 4, right? 6 and 4, they have to add together to 10 because we're given power 10. And then combinations, 6 is chosen out of 10. 10, comma 6. So it's always going to be out of 10, out of total. And then you select whatever power of x we have. So it should be same for all of them. So what's with x to the power of 6? Well, there'll be two things to multiply, right? So there'd be some big number. So you just put this in the calculator and that's it. So let's go here. So our, again, combinations. So I need to select out of 10, back to main, 10, comma 6. And then multiply this, put times -5 to the 4th. We'll just put it in the parentheses the way it is. -5, then the power is 4, and big number. It's going to be 131,250. Okay. 131,250. So definitely the calculator will help a lot. Right? So does anybody want me to do with some other digit, the same thing? So what if my digit is 0, Alex? Okay, put 0 where? Well, the power is going to be 0. Right? Just want to show you that this is the same thing, just different numbers. So what's power of -5? Well, instead of 4, it must be 0 and 10. That gives us 10, right? So 0, 10. So the combinations out of 10, we need to choose our power of x we have, 0. It looks like that'd be our very last term. And again, it's a calculator exercise. So x to the power of 0, which is 1, so you don't have to write it, or if you want, you can definitely do this. But question is, what's the coefficient? Well, let me put this here. I can just replace with a 0, can choose 0, and then -5 is raised to the power of what? 10, right? So let us put 10, be a huge number. 9,765,625. Okay. 7 million and 765,000. Okay. 9 million. 765,000. What was it? 625. So whatever it is, please notice it doesn't matter what your digit is. You just put all that in your calculator. And take it 625. It should be ended with 0. I think. Let me check it again. So, no, 625. 625. See, calculators know better. That's why advice is better use a calculator. 6. So you have to multiply -5 with itself so many times and get the result. Well, interesting. Practice using your own calculator, and that's the way to go. So you can try whatever other digit you have in mind and put it in, and I'm sure it'll be same amount of work. So for Monday final, we're gonna discuss it more on Friday. This Friday, we're gonna have a very last class meeting, and I wanna see if you have any questions for me, if you be practicing and doing problems, and if you want my help, I'll be definitely more than happy to do this for you. There'll be two questions, so one will look like this, and the second question I will discuss on Friday, but it's coming from section 3 of chapter 12. So you can check out this exercises with conversions of geometric sequence series, actually here, the series, and there is a formula that we were using this theorem, that formula. So that's what I want to discuss next time on Friday in more detail. I think it's something that we should definitely refresh. It's a great material. And also homework will be due. The homework is also due on Monday. Yes, I can give a couple of days extension, but try to prepare it for Monday. Why not? There's not much was covered. It's sections of chapter 12. We did 12.1 through 12.5, right? And also we looked at chapter 13, where we used only one section. It was section 2, 13.2. So we did quite a bit of problems in class from these sections. And as usual, for the homework, I will ask you to do whatever you like, whatever I done, just a couple of problems for practice from each of these lectures that I was sending to you. So as for the midterm, you can email me your homework. And of course, if some people ask me, Alex, can I return my old homework, turn in my old homework? Yes, I will accept it, but I never got it. So if you ask, just send it to me, because I will accept it, of course. So finish it up over the weekend, whatever you've done. So just send me homework 1, and this is homework 2, to make sure that you clarify what is that you sending to me, right? Because I might get mixed up, because lots of emails are coming, and some people like to put the midterm also inside, and they put first page of midterm, first exercise somewhere on the 3rd page of your homework package, and the last exercise on the 5th or 10th page of your package, and you expect me to dig through it real carefully and read all of these things and find where the midterm is. I look at the homework, I see if it's been attempted, so I give you a full credit for it. So that's why, just when you send me something, make sure you clearly show midterm, send it separately, separate email. Homework 1, separate email. Homework 2, separate email. That way you're not going to lose any points for sure. So make sure you keep those points, because sometimes say, Alex, I already sent you midterm. You're asking me for it again. Yeah, I was somewhere stuck between pages of homework. So why don't you just send it to me separately? And that way, for sure, I'm not going to be sending you a reminder email saying, so where is your final? Where is your homework or something? Okay, because I getting lots of emails, and sometimes it's being overwhelmed. So anyways, please keep this in mind. And I guess now you know what to do for homework. So just these, 5 and 1, 6 sections, not much. And you have everything in my lectures. So just look at the lecture recordings. Okay. So I guess that's all I wanted to do today. Next time we're gonna continue. We're gonna do more from section 12.3. And of course, I want you to try these problems first, and then maybe I will do some more of exercises of a type that I just done again on Friday, if you request it. So please, before Friday, try to redo a couple of problems that I've done today. So I think like problem number 29 will be great to look at because it asks exact same question that I did. Number next to it is a little bit different, right? What was it? Okay, right down the number because it actually doesn't clarify what power of x to deal with, which makes it be a little bit more work, I would say. But I give you on the final something more straightforward kind. So that was exercise number, let's see, 12.5. What was that? The third term, 37. So 37, that was another one I did. So anyways, if you don't have any questions, now you know what to do, right? So for Friday, try to finish up with homework. That'd be a great plan. Well, if not, you can just at least start it and tell me how you feel about it, right? And I'll let you go today, so we're not gonna have any more quizzes. I'm gonna stop recording. So have a great rest of the day, and we'll continue on Friday with the midterm, our last day of class, basically, because Monday will be the final. And of course, after the final, it will be on Zoom on next week, Wednesday, as well as Friday for you if anything is needed, for just in case.